Okay. Where you completed your this one tool and die?
BTC.
BTC center. Which year?
2018 pass.
2018 pass out. Okay. Nidin SS. I know him. He was my batchmate in tool and die. I am also basically a tool and die maker. So my name Sharath Raj. Okay. So I'm basically from Kerala. So I'll be taking the class maximum in English, because if I only take in Kannada, there are also people from Bhopal and all here. I can't take this. So if you have any doubt, if you want to ask that time itself, you can ask. Or if you want to note it and ask later, you can ask at that time also. Okay? Any confusion? Any doubts? Okay? Anything you have. If you feel also, what will happen if it is not correct answer, or if it is a foolish question also, ask. No problem. Because one person's question will be an answer for another person. And another person will learn from that. If you are asking wrong, maybe he also has that thing in his mind. That same wrong question he also will have. So it will be helping him also. Okay. So today, now it's already 11. What we'll do, we'll be starting on the basics of CNC. Basics of CNC. For those who have already studied this, since this is a theoretical subject, you may feel little down, much bored. Don't feel bad about that. For others, because those who don't know anything about the CNC, have you guys seen the CNC machine at least? You have seen?
Yes.
You have seen the CNC machine, right? Okay. Now we have one. We have one CNC machine down in the ground floor. You can just go while going. You can see that machine also. So, what is CNC? What is CNC? Computer numerical control. What does it mean? What does it mean? Computer numerical control. Don't think more, just from the words. From the words, what do you feel it is? Oh. Basically, it is a machine controlled by computer numericals. Don't think more and out first itself. It's a machine where we will be sending the program to the computer, and this program will be accepted by the machine, and the machine will run the program by using a set of codes, which is called as G codes, M codes, which we will be learning later. Now, what are we going to do in this class? So, we will be understanding what are CNC machines. We will be understanding what is the CNC machines. Then, we will be operating and programming on CNC machines. And we will make simple parts. We will be making it. If you don't have any experience in CNC, nothing to worry. Okay, everyone was once a fresher in everything. Everyone was a fresher. It is how we have the interest in doing the same thing. For example, when you are driving, when you are small, you like the driving very much. But did you drive? First time when you sat on a driving seat, were you confident? You were afraid, right? We have seen all the people driving. We might have played games. Everything we might have played. But when it comes to real life, there was a first time for you. First time when you walk, you have fallen many times. So, don't worry that you don't have any previous experience. You are going to learn it from me. Now, what is a CNC? The expression for CNC. CNC, or the computer numerical control, it's a system where computers control the machine tools automatically using the programmed instructions. So, every moment, each and every moment, we'll be telling the machine, go to that point, go to this point, go to this. What we give, the machine will do as per what we tell. That is the main thing of CNC. So, when I tell CNC, do you think it's only CNC milling or CNC lathe? So we have many types of CNCs. We have many machines in the range of CNCs that we will be learning here. Today's class will be just introduction. Introduction to, since we don't have much time. So, first let me ask you, this CNC, how many of you know addition and subtraction? Tell me that. Addition and subtraction. In maths, what is addition? We are adding. What is subtraction? We are minusing. Here, in the same thing happens in the machine world also. We have additive manufacturing and subtractive manufacturing. Subtractive manufacturing. Additive and subtractive. What is the difference? Just like what we told in maths. In additive, there will be nothing. And from that nothing, we will build something. From the bottom, it will be formed. Remember, in earlier time, we had a, long back, when I was from the school, there was a program in TV, a Hindi program, Shakalaka Boom or something like that, where the person will draw something with the pen and that comes right in front of the person. Similarly, here what happens? There is nothing, but we are making that. From the base, it will form. From the bottom, it will manufacture and it will form. Whereas, what happens in subtractive? Subtractive is nothing but we have a block, we have a piece, we are removing the unwanted part from that, and then the remaining which is there is the material. Understood? That much you got. What I meant you got. Understood? Any doubt in that? So, CNC, the CNC operation is always a subtractive manufacturing process. It's a subtractive manufacturing process. This additive manufacturing, we have only example of this 3D printers, 3D pens, all those things are additive manufacturing. And the CNC, wherever we remove the material, that is the subtractive manufacturing. So, as I told, additive manufacturing, material is added layer by layer. Layer by layer. For example, if in a plastic, you are putting a plastic wire, it is getting melted. We put it down. Imagine the mehendi. How we put the mehendi? One layer on top of that, on top of that, on top of that. It will come big, it will be joined, right? The same thing is the additive manufacturing. That's the principle of 3D printers also. Now, in the subtractive manufacturing, the material is removed from the solid block. There will be a material, we will be removing it from that. Now, what are the importance and advantages of CNC? Importance and advantages of the CNC machine. First thing, it is very fast and accurate. The work in the CNC which are doing, we can do in the manual machines also. We had manual machines earlier. We have manual machines now. But these dimensions, when we come to the dimensions, first thing, all the mechanical people know, others I am telling, once you enter a machine shop or once you enter a company, all the measurements will be in mm. Mm means millimeter. We won't be using centimeters, we won't be using any other thing. But outside India, some countries, they will be using inches. So, mostly we will be using only millimeters. So, how much is 1 centimeter, how many millimeters? Any idea? 1 centimeter is basic, school level basic, 10 mm. What 1000? 1 cm will be 10 mm. So, whatever we calculate from now, whatever we see from now, will be mostly in mm only. only in millimeters. So even what is this millimeter? If you take 1 centimeter, 10 parts of that. That is the, if this is 1 centimeter, we divide it to 10 parts. This is 1 centimeter. This centimeter will be divided into 10 equal parts. And this each part is called millimeter. Now what will happen when we do it as CNC operation or something? We will be again dividing this 1 mm into multiple parts. These small parts, this small 1 mm, we will be dividing into 1000 parts. 1000 parts, and each part will be known as a micron. A micron. So, what is happening in the accuracy? A material, if you are doing, sometimes very thin material will be doing. Imagine an item for eye operation. An item which we use for eye operation. It will be small, just like a small piece. The size of that will be, for example, 2.355 mm. 2.355 mm. So you have to think 2 mm itself is very small. In that too, we are going to make 0.355 also. Manually, can we get it? That much accuracy. We won't get the exact size. It may become 2, it may become 3, or it may become 2.5. But when it comes to the medical field and all, if this 2.355 mm becomes 2.4 mm, that is basically only 0.5 mm is difference. 0.5 mm is very short, we can't even see in the eye. But that is also a problem. We need the perfect size. So to make it, we have to use the CNCs. And this will happen very fast. For example, we have to make 1000 pieces. 1000 same type pieces. We can always say that the first piece and the last piece, 1000th piece, we can always confirm it will be the same size, same finish, same accuracy, everything. But in the manual what will happen? We have to set everything manually, one thing. Second thing, after doing 5 pieces, the operator will be tired, or he may get a phone call, or he may start thinking of something else. He may in the dream world, something will happen. So what will happen? That piece, the accuracy will go. Accuracy will go there. So in such situations, what you have to do? We cannot assure that the first piece and the last piece will be the same. And in the manual, what will happen? You have to always set it manually. So it will take more time. Whereas in the CNC, it's all set. Once we load the piece, all the tools will come, it will all set everything and it will go fast. So that's why, and it can make any complex parts. Any complex parts can be made in the CNC. It will save time and cost and reduces human error. But there are chances of human error here. What are the human error chances? What will happen if we put the wrong input? If you make the program wrong, who is making the program? Program is made by humans. So what if there the mistake happens? So that's a human error. For example, then instead we have programmed everything in mm. Normally it's a common practice. But when you are giving to the machine, by mistake we wrote that it should be taken in inch. Mistake will happen. The size will completely change. 1 inch is equal to 25.4 mm. 1 inch. 1 inch is equal to 25.4 mm. That is the value. So once mm to inch gets confused, the entire design will change, entire size will change, and there are chances for breakage also. Now, supports batch production, as I told. Supports batch production. What is batch production? we are making 1000 pieces at a time. The same piece we are making 1000 numbers or 10 numbers, 100 numbers. That's a batch production. That will be supported by the CNCs. Now, coming to the history of CNC. So, first, it was the manual machines, as you can see in the image. It was the manual machines. Then, it came to NC machines. We have the NC machines. And then came the CNC machines. So, what is NC? What is the difference between NC and CNC? NC, CNC. Yes. The difference is there is no C. Why? What happens? From the manual machines, when they went to the, when in the starting, a person, how it came is, first time, a person was making a blade. Helicopter rotor blade, you know. This blade he was making. Everything was done in manual way. So he understood that he is losing time. The work is not coming properly. So that is when this person, the first person, started making a small program. And that time, it was done into the punch cards. A punch card system. A punch card is something like, I don't know how many of you remember the floppy disk? Floppy disks. Everyone knows floppy disk? It was all our old memory card. So before floppy disk, we had the punch card system. So what he did, he will program he will enter all the values in the punch card and input in the machine. So machine will follow the punch card system. There is no computer at that time. There is no computer at that time. So after that, after the NC systems came the CNC. In the around, this NC systems actually came around 50s or 60s only. 1950, 1960, that time. Only at that time, the NC system or the C of the CNC was brought, inserted. And because of that, what happened? The current situation came. So currently, what is happening? Everything is CNC. I know some companies, they are trying to get a spare part for some machine part or something. They try to get from the market. No, they will tell it will come only after 1 month or 2 months. What they will do? They will take a block, they will make the item. Okay, there are problems there. What will happen? The item which you can buy for 50 rupees, you will be manufacturing for 200 rupees. That problem is there. But what is the main thing there? You save the time. Because the purchase to get the item from outside, we need almost 2 months. And 2 months if the machine is idle, what will happen? In company, each minute the machine is on, makes money. And when the machine is off, loses money. Because all the CNC machines or whatever product it is, it is for basically for making money. Why is CNC we do? We want to make our work easier. We want to earn more, right? We want to earn more. Otherwise, if you want to earn less, no need of cost or anything, you can buy a small old machine, old normal machine we can do and we can do in that. No, we want precision, we want speed, and we want the accuracy. Okay. Now, coming to the history, I told you already about the old thing, about the rotor thing. So, in 1955, they had only the tape controlled machines, which I told you now. I told you the NC systems. 1955, around 1960, there were only in Chicago, there were only 100 machines. Only 100 NC machines. Around 1960s, Japan entered the NC commercial space. Japan came to, till that time, America was telling, I have the highest CNC systems, all those things. As usual, Japan came, overtook America, and they became the top. By 1965 to 70, the computer was introduced. Computer of the CNC, C. C was introduced in by around 65-70. By 90, CAD CAM softwares include. What is CAD? What is CAM? First, you have to see that. What is CAD? What is CAM? What is CAE? First thing when you learn, base thing. What is CAD, CAM, and CAE? What is CAD? Computer aided designing. Computer aided designing. What is CAM? What is CAM? Computer aided machining. People say manufacturing also, it's okay. Computer aided machining. What is CAE? CAE. Analysis. It is engineering, but it's analysis. What we do there? For example, we designed a JCB. Imagine we designed a JCB in 3D. Now, once we design, we have to see how it moves, how much the bucket, how much it will go up, how much it will go down, how much it will turn left, how much it will turn right. These things will be checked using the CAE or analysis. We have the analysis softwares for that. Okay. Now, CAD softwares. What are some of the CAD softwares? SolidWorks, AutoCAD, CATIA, NX, Creo. Creo is actually the renamed version of Pro-E. Pro Engineer was a software which was later converted to Creo. Then we have Rhino software, Autodesk. All those things are CAD softwares. Now, when you come to CAM softwares, which are some of the CAM softwares? We have SolidCAM, we have MasterCAM, we have Symmetron, we have many options. But here, in these 45 days, you will be learning SolidWorks and SolidCAM. Why? Because once you learn SolidWorks and SolidCAM, you cannot say when you are going to a company next, there this software will be used. Multiple softwares may be used because they may have license on another software. We can't tell them, okay, no, I learned this, I want that software. They won't do it because each license costs money. So what will happen? Once you learn SolidWorks or SolidCAM, any other software will be easy. It's like basically you learn to drive in a Maruti 800. You are driving Maruti 800. Later, if you go to Innova or Benz or anything, items are the same. Same as the accelerator, brake, okay, clutch something different will be there, that's okay. Manual ones, clutch, everything will be the same. Will there be any difference? The basics will be the same. Easiest is the Maruti 800. That's what's happening in the SolidCAM also. Easiest you are learning. So once you go into the next stage, it can be easy. Then, so by 1990, CAD-CAM was introduced and the current situation where everything, what's happening, the robotics, all the automatic things. Now, even the humans are not required to even load or unload, right? Everything is robotic now. But still, human presence is needed. So, types of CNC machines. Types of CNC machines. We have 3-axis CNC machining and multi-axis CNC machining. What are axis? We have detailed class on axis later, but still I am telling you, axis means in the school when we are studying, there will be like this thing, right? The graph sheet. Remember, we have learned x-axis, y-axis. But here we have 3 axes. We have the z-axis also, which someone called as c-axis, z-axis. Okay, and this x, y, z are the 3-axis machine. And we also have the multi-axis machine which will have the 4 axis or 5 axis. 4 axis or 5 axis will be the rotary axis, rotating axis. So in the 3 axis CNC machining, we have CNC milling and CNC turning. In the multi-axis, you have index, continuous, mill turn. Mill turn. Milling is for square objects or any objects, and turning is for mostly round objects, circular round objects. To make round objects, use the turning. So we have the mill turns, which will do the both the work of milling and turning. Milling and turning, it's called as mill turns. That will come in the multi-axis machine. Any doubts till now? Any doubts till now? Index machine is a type of machine. I'll explain it. So, what is happening here? Either the tool or what is a tool? Tool is the thing used to remove the material, right? Whenever we say tool, it means cutting tool. Cutting tool. Just like a knife. What does knife do? What will knife do? Remove material. Cut material, right? So, whatever I tell, tool is a cutting material. And whenever I say job is the workpiece which we are going to machine. Keep that in mind. Job will be the workpiece which you are going to do. The work which you are going to do. So in this, what happens? Either in some machines the job will be fixed and the tool will move. In some machines the tool will be fixed and job will move. In something, both will be moving. In some machines. So the cutter will move on 3 axes. In the 3 axis machine, it will be moving on the 3 axes. What are 3 axes? X, Y and Z. X will be from left to right. Left to right is the X. It's going from left to right. And what about Y? Front to back. Y is from front to back. And Z is from, Z will be always up down. So, X will be from left to right, Y will be from back to front, and Z will be from top to bottom. Understood? Understood? Any doubts? Any doubts? Now, what about the 4th and 5th axis? It will be the rotating ones. So, say 3-axis milling machines. It is the most common axis machines available in the world. Why? Because it's comparatively cheaper and it can be operated easily. It can be operated easily. Whoever starts a tool room, whenever a person is starting a tool room, what he will have? He will only have a 3-axis machine. No one will start with a 5-axis machine. What we will do? The work which the 5-axis does can be done in 3-axis also, but it will take more time. But initially, when I am starting a new company, I cannot invest crores in the 5-axis machine, can I? This 3-axis machine will cost around some 45 lakhs, 50 lakhs. If it is 55, 45 lakhs, The 5 axis will be the double or triple of them. So initially we will be putting the 3 axis machine. 3 axis machine, the main parts are, see, this is the workpiece, this will be the base, this is spindle and the tool. So the spindle will rotate along with the tool. Along with the tool, the spindle will be rotating, and when it rotates, it will keep on removing the material. When just a paper, if you take a normal paper, take a pen, if you rotate it, will it tear? The paper will tear, no? Similarly, when a rotating object has a, since it has a blade also, a sharp edge also, it will be keep on removing the material. So this is the basic idea of a 3-axis machine. So in the real world, it will be like this. On the base, we will be clamping a vise, or directly we can clamp and do the machine. One thing we have to make sure is the piece is perfectly kept. We are not, it is not with loose or anything. Now, another issue with the 3-axis. Now, I have a box. Okay, I have a box. All the sides machining is there. I have to do machining in the all the sides. What will I do? First side I do. Then I will remove. I will keep the second side. I will set all the things again. Again I will keep the third side. I will set all the things again, and I will do the fourth side. Whereas in the 5-axis, what will happen? We will fill it once, and all the side will be done in the machine will turn the piece automatically and do the work easily. What is the main difference between 3-axis and 5-axis? Understood? Any doubts? Any doubts? Now, CNC lathe, or it is called as turning. What is meant by turning? Just I am asking about English turning, not, don't come into machine or anything. Turning, what do you mean by turning? Turning means, it's just we turn. The same thing is happening in the CNC machine, CNC turning also. But we will be using lathe. For round of this, we will be using lathe. What will happen? In this chuck, here the item will be caught in a chuck. It's called a chuck. This chuck will act as a spindle. This chuck will act as the spindle, and it will be rotated. The chuck will be rotating. Earlier, what happened? The tool was fixed. The job was fixed. Tool was rotating. Here, the tool will be fixed, and job will be rotating. So, here you can see, in the chuck, this chuck, normally we have 3-jaw chuck, 4-jaw chuck. Why do you want 4-jaw chuck? This 3-jaw chuck is easy. In the center, a round chuck. In the center, we keep the work. There will be 3 jaws. When we tighten one, all goes equally and tightens. This is easy. But there are cases where we will have to machine square pieces. Sometimes we will make a square piece into round, or if you want to remove the front part of the square piece, but to remove more, we will put in the lid. That time we will use the 4-jaw chucks for the square pieces. So here you can say chuck. On the chuck, the material is kept. On the chuck, the material is job is kept, and this will be continuous rotating. Like around, for example, it will be around 4,000 RPMs, 8,000 RPM, 12,000 RPM, 25,000 RPM, 1 lakh RPM. It will be rotating in that much speed. And then we have the tool. The tool will not be moving or anything. It will be fixed in one place. Then the whole tool setting will move. Tool will be fixed. The tool setting, where the tool kept, that will move and remove the material or do any required operations. Understood? The difference between the milling and turning. Milling and turning. Any doubt? Any doubt? For beginners, I am asking. Any doubt? Huh? Now, parts of a CNC machine, whichever CNC it is, the parts will be common. The parts of CNC machine, we have the machine body. Machine body in sense. So structure. Machine body is the structure. Then we have the table. What's the purpose of table? Table is used for keep the workpiece. We have a spindle to rotate. We have the control panel. Huh? Not where the people give the instructions. How we insert the programs, where we insert the programs. Then we have the tool changer. What is the tool changer? Because some CNC machines, we can install 24 tools. 12 tools are there, 24 tools. Tools are the cutters. For example, there is an end mill, which I will show you later. End mill. There is a different sizes. The 5 mm, 1 mm, 20 mm, 30 mm. All those things. We will be using multiple tools in a machine. So what will happen? Once one work is over, we will have to load the next tool. Manually, everything will be very difficult. So a tool changer, what it will do? It will call the required tool automatically. It will change the required tool automatically. Then we have the coolant system. What is coolant? It's an oil. It's a liquid. Because when the tool is removing material, what is happening? It will generate heat. It will generate it. So what should happen? The material should be cooled. The tool should be cooled. The job also should be cooled. Because once it is not cooled, the job is not cooled, it becomes more hot. What will happen? The properties of the job changes. The properties of the job changes. For example, you know the material called MS, mild steel. It's one of the softest steel. If we overheat it, it will become hard. The material will become hard. Then we cannot do the next operation on it. Once it becomes hard, it will remove the properties, and we cannot remove the material from that. Understood? So that's why you use the coolant system. Other than this, we have the pallet changer also. Pallet changer, automatic pallet changer. What is that? Second table. Second table. When we are doing a machining inside, another table will be set outside. We will be setting everything. So because it's a long sitting. Once one work is over, that table will come out. And this pallet will go in. So what will happen? We save the time. So some machines will have the pallet changer also. Then the main components of the CNC. Main components of CNC. What are the main components? First one is the machine control unit. The machine control unit, or we can tell it's a brain. It is the brain of the machine. It controls, as the name says, it controls what program we are going, all those things. Then we have the drive system. What's the drive system? What's the drive system? Drive system is the system which moves on various axes. We have to move, no? There will be a screw or something which will help the machine to go in various axes, as we tell. Then we have the feedback sensors. What is feedback sensors? Feedback sensor is nothing but the machine is moving. The machine just like moves like this, anyway it will move. But the CNC should know now where it is, whether it has gone to the right place, whether it has moved only 10 mm or it has more. All these things will be given by the feedback sensors. If the feedback sensor sends, okay, it has gone little over, what will it will correct automatically and come to the normal place. Then we have the machine tool which I already explained, and then we have the operator interference, operator interface. What is the operator interface? It is a screen which we will be communicating with the means of communication from us to the machine. Now, I told you CNC, there are many types of CNCs. What are the types of CNCs? CNC is just computer numerical control, but we have many machines in that. We have CNC milling, we have CNC turning, we have CNC EDM. What is EDM? Electro discharge machine, where the current will be transferred from one piece to another and material will be removed. EDM, we have in EDMs we have wire cuts, we have spark machine. All these things come from the EDM. We have CNC router, we have CNC laser cutter, and many more. But we are here concerned with only mainly CNC milling and turning. Why? Because that is the most important thing. Other things we can just, if you go near the machine, stand for some 5 minutes or 10 minutes, we can learn it. And this CNC turning itself, we cannot 100% guarantee that we will be learning here. Because every day, each and every day, maybe after 45 days or 45 years, if you have 45 years of experience also, next day you will be learning something new. You will be learning something new. Every day, each and every day, we have to keep on learning. We have to keep on updating ourselves. Sometimes, some of the settings we may not know in the initial stage. We'll be knowing it later. It will come and we'll be learning it. It will take time. But basics, if you know, only if you know the basics, you'll be able to do it. Now, what does an operator do? What does an operator do? CNC operator. What is his duty? His duty is to load the tool and workpieces. 0 points. 0 points is the 0. I'll explain it. Run the program, check the parts, and follow the safety rules. These are the main thing of an operator. Now, loading tools and work. All these things are very, very important. And one operator, the best thing of CNC versus the normal one, the best thing is in a normal machine, one person is required for one machine, right? One person is required for one machine. But in the CNC, what will happen? The best benefit, you appoint one person, you have 5 machines, he can do everything. He can control all the machines. Because once he wants the machine, then he is free. He has to check it in between. In the meantime, he can go to the second machine, run the program there. Then go to the third machine, fourth machine, fifth machine. Then he can come to the first machine. So, one person can handle multiple machines. And that's also a reason why you get a better salary here. But the main thing, when you work in a CNC programmer, a person can become CNC programmer. But before knowing becoming a programmer, the first thing he has to do is, he has to be an operator. Because once he knows what he is doing, he can program it easily. Understood? Understood what I meant? If he knows, okay, these things are going to happen in the machine, he can program it as per that idea. Otherwise, what will happen? It will be like studying swimming through distance education. How it will be? Studying swimming distance education. We are just sitting in the system, watching in the TV and learning swimming. Will it be of any use? So first we have to get into the water. So similarly, first we have to get into the machine. Then we can program it easily. So what are the main safety rules in a machine tool? When you are working, you have to always wear safety shoes and glasses. Then no loose clothes. No, you should not put any loose clothes. No touching of the moving tools and use the emergency stop. That's the most important thing. Always know where is the emergency stop and be ready to press it. You feel anything is wrong. Okay, I feel it's not good. It's not correct. Press it. Stop it. Maybe you will lose 2 minutes. You will lose 2 minutes. But that 2 minutes lost will save money and effort later. If you don't do that, let it continue. We'll see what is happening. The cutter may break, the job may be damaged, all those things will happen. So which is better? Stopping it in